Welcome to the factory of programming. Prepare your mind for exclusive tech experience. Listening to Vivo Bon right now.
Hello, so today we'll see the feature of pattern matching for switch. So what is the problem that solves pattern matching for switch? Before Java21, switch works only with int, strings, and enums, and case labels must be constant. So it implies complex branching, chain of if-else with instance of, if you want to use other stuff, and this provokes boilerplate cast. It is error prone, and it is hard to ensure exhaustiveness. So what is the goal of pattern matching for switch? It is to make switch more expressive and type safe, to allow patterns as case labels, to integrate null into switch safely, and to ensure exhaustive handling with sealed types, for example, and also to keep backward compatibility. So what is the evolution that took place from instanceof to pattern switch? So before, in Java 16 and more, we had to use instanceof. So we have this kind of code. If s instance of rectangle, then something that uses the properties of R. And else if s instance of circle C, then you use the property of C. But now, with Java21 and the pattern matching for switch, you can directly use the type in the case, and their properties directly in the case body. For example, return switch S, case rectangle R, arrow operator, and then you use the properties of the rectangle R. And same for circle. And you have also a default statement which allow you to throw a new illegal argument exception when there is no thing matching the type of the argument of the switch. So, no cast, clearer and safer. Then, pattern matching for switch, the type supported. Now with this new development, in the selector you can use any reference type. This means object and int. Other primitives are excluded for now. And case label can be constant, pattern, like a class, record, array, or null. So let's see an example of type patterns. For example, I declared a record point, an enum color with 3 values, red, green, blue, and then I have a little method, type tester, which take as argument an object of type object, and then there is a switch which is which takes this object in parameter. And you see, you can have a case with null, case with string, case with color, case with point, the record, and a case with an array of int. And also a default option. So you see, you have all these kind of type patterns. Then let's speak about a grounded pattern with the when clause. So, for example, we get back to a function test, which take an object as argument, and then you can use in your switch, in your case of the switch, when clause. For example, case string s when s dot length equal 1, then you do something. So this means you have to abide to this condition to then reach the body of the case statement. And then you have other case statements, but here is the when clause. So it is cleaner than splitting it to if-else inside case. It avoids you to write boilerplate code with if-else, and you just have to put a when clause in your case statement. Then you can use enum, Before the new evolution, you have to define the type suite S and then use a guarded pattern when S equals suites.club, and now you can directly use case suites.clubs. You don't have to define to write the type and then use a when clause. You use directly the value of the enum. So it is direct, readable, even across sealed hierarchies. The null in switch. All behavior switch on null provoke null pointer exception. No, you can use explicitly null label and it is supported. For example, you can have this kind of statement, case null, and then arrow operator, and in the body of the case statement, you put something related to the null value handling. So you decide whether null is handled or no. Exhaustiveness. So exhaustiveness means you have to comply with all the possible case when you use a switch, the switch statement. For example, switch must cover all possible values. It is a way to ensure the ways to ensure this is to use defo label. It is for example, it is a way to say that if you haven't matched any condition, you can have a defo label which will be executed by default. So the name is defo label. Then for enum, you have to cover all the enum constants, and for seal type, all the seal type subtypes. For example, here I have a seal interface, S, which permits ABC. So I define ABC, and you see in the switch related to the seal type S, I have to declare 3 case statements for each of the subtypes of this seal statement: case A, case B, case C. So no defo needed, compiler ensure completeness. So if you are exhaustive, you don't have to put a defo label. Then dominance rules. So to get clear, you have to be vigilant to the order of your case statement so that there is no overlapping. Like here, your string S is unreachable because your sequence is just before. And so takeaways: switch now works with pattern plus null, safer and more expressive branching, exhaustiveness granted by compiler, enum plus seal hierarchies supported directly, and above all, there is much less boilerplate. Thank you and see you in the next video. Bye.